Arrays. Let's talk about how we can make them easier to use and more flexible in C++. So why should we use standard vector instead of a plain C-style array? Well, there's a lot of advantages. C arrays are fixed in size unless you manage memory manually with malloc or free, or new and delete. Or you could create your C-style array in global space or on the stack, but still, it's still a fixed size and you're pointing to a location in memory. Remember, all arrays devolve into pointers. Standard vector is a dynamic add with the capability to remove elements, and it resizes itself automatically. There's no manual memory allocation or deallocation needed. So this makes them very safe. In C arrays, when you access an out-of-bound element, it leads to undefined behavior. Standard vector has built-in bounds checking. Now they have methods such as @, or you can use the bracketed notation. If you go out of bounds, you'll have some indication through an exception, and you will know what happened. C arrays require manual shifting of data for inserting or deleting elements. If you think about it, you created a C-style array. What if you want to insert something right in the middle? Well, that's a bit of a problem. It can be done, but you're going to be writing a lot of C code to make that happen. Standard vector, it's built in. The code has been written, it has been thoroughly tested, and is super reliable. It has been around for at least 20 years, well, probably longer, 30 years. With standard vector, you have functions called pushback and placeback or erase. Memory management, again, if you forget to use free or delete in C, it would be free. And let's say you malloced a chunk of memory, you point to it, and now you're treating it like an array. Not to mention you're going to have to figure out the size you have to use size of, making it quite complicated, very easy to make a mistake. With standard vector, you pass in the type when you create the container, and all that is handled for you. Another cool thing about standard vector is you're able to use the algorithms classes, so you can do things like search, or I should say search, find. It also has things such as sort or min and max. There are a lot of iterator-based SDL type algorithms that can be used to manage your data more effectively. One of the other things that is useful with using standard vector is you have methods called size and capacity, and you also have a method called reserve. Very handy. Size gives you the how many elements are in the container. You don't have to know the size of the array ahead of time. Capacity, well, how much memory was reserved. That way, when you insert or delete in from the vector, it's very quick. And finally, some of the critiques made about C++ and SDL containers, it's going to be a performance impact. It's just simply not true. It is still using C code under the hood, or what we would call C code compiled with a C++ compiler. All the array type functions and pointer work that you did when you were in C is being done in that class under the hood. What is happening is it's been abstracted out to make your life easier, to make you more productive, and to prevent you from making mistakes. Now, yes, could you write it in C and optimize it to get it a slightly bit faster? Probably, yes. Is that going to really matter in like 99.9% of the cases? No. It won't. So keep that in mind when you hear criticisms of people who have used in C++ and the STL library. In my opinion, it's unwarranted, and a lot of times it comes from a lack of understanding of what C++ is capable of, and some people are just afraid to try something new. So let's recap why we want to use standard vector. It's safer, it's easier to manage, it's compatible with C++, and if you're serious about leveling up from C to C++, this is one tool you need in your arsenal. It is what you need to do arrays in C++. Now, let's get on to the example. So in our first example, we're going to take a simple C-style array. I'm going to go through it and we're going to explain the pitfalls of doing this, and maybe some of the advantages, although there are very few advantages here, but we will try to discuss them. So this is a simple C program. I'm using a C++ compiler. Now keep this in mind. We're going to be using a C++ compiler, but we're going to write C-style code, which is perfectly legal to do, which is the whole point of these videos. to use the C++ compiler, and as a C programmer, learn things that makes your coding more powerful, more simpler. And if you want to become more of a C++ programmer, yes, you can do that. Or leverage all the advantages of C++, the standard tempered library, and create robust embedded systems or even applications. So in this first case, we're starting with a simple C-style array. It has a size of 3, and each of the instances of automobile, which will be this class right here, stored in this array of cars, will be stored in memory. Now, it will be stored on the stack. Okay, we are inside the main function. All of this is stored on the stack, which is my first pitfall. Yes, we can create a simple array. Yes, we can do a lot of work with that. It'll be fast. It's C. Great. It's all great stuff. What if this array gets really large? What if we need to store a lot of information in this array? Well, you're going to run out of stack space. And as you call more and more functions inside of this function, you may run out of stack space. Your stack pointer may go to a point where you have no stack space left to use anymore anyway. But for small arrays like this, and in this example, it's perfectly fine to do. And there are many C programs that would do something like this. And then when you leave the function, that stack space is reclaimed and makes the program basically more lean and mean. So in this case, we're going to use this initializer array to make our life a little bit easier. We're going to stuff the cars with these 3 examples: a Toyota, Honda, and a Ford. Now we have some code here at the end to print it out to verify that it's doing what we said it would do. It does build, and I will run it. Okay, it stops at main, and then we're going to hit run, and it's done. You can see right here we have it prints out the 3 cars. It was fine, no errors were thrown. Typical C-style array. Simple. We're using index notation to access the members of the array, and make, model, year, and price. Now we could use pointers, but as many of you that are experts in C know, that arrays devolve to pointers under the hood by the compiler anyway. So this notation is perfectly fine, and it's a perfect first example for us to look at. So the other pitfall is, not only are we stuck with a size up front, number of cars, we can't add to this, not without some clever trickery, and plus we're on the stack, which makes it even more impossible to add onto this. So adding onto this is not that easy. Now in the next example, we are going to add onto the array. We're going to use features that some of you are familiar with, called malloc, memory allocation. And I will show how you can take a vector and you can have it grow dynamically on the heap. All right, with the addition of I added a fiat in between, and I printed it out again. The size of the array went from 3 to 4. We are able to add onto the end of the array the additional car. Now, if we look closely what happens when we add an automobile, we pass in certain arguments such as the capacity, and these are all by pointers, and then we call the resize array function, and what that does is it reallocates the memory. It's another command similar to malloc. It's going to take the capacity, and then it's going to multiply that by the size of the automobile. Okay, we're going to probably clean that up and just say, as we can see here, with the additional functions of add automobile and resize array, we're able to grow the size of the cars array by 1, and it does not throw errors and works nicely, and it's all being stored on the heap. Now I want you to take a look at this, and this is where I think, C is a great low-level language, but look what we have going on here. Lots of pointers, lots of malloc, lots of checks for null pointers. There's a lot of places here where this program could possibly blow up. Now, in a much larger system, you may have a sophisticated architecture. A bug in something like this would be very difficult to track down. You have to be very careful up front how you do this. You have to remember to put free at the end of your function. If you do not put free at the end of your function, you get a classic memory leak. And then every time you allocate more memory on the heap to store more information, that existing allocation that was there before is still there. And then it looks like the amount of memory you're using keeps growing and growing and growing. It's what they call the memory leak. But if you're careful and you do it right, this is perfectly a legitimate way to do things. And if you have a small system where all you have is C, well then yes, you have to do this. But a lot of embedded systems currently, they're not only are they now 32-bit, you can now use C++. There's no need to have to go through all this, jumping through hoops to get a simple array that you can dynamically increase. And stand by, I'm going to set up the next example. Okay, in our final example, I'm going to show you how you can avoid all the hassles having C-style arrays by using C++ and the standard template library. And the template we're going to use is called the vector, and it's probably one of the most used templates in the C++ world. And it's very easy to use, and you'll find that it's a lot like using the array in practice in your coding. But in terms of safety and ease of use and being dynamic, it is way easier than what we implemented on C with using malloc, traditional arrays, pointers, and the like. So here we go. We're going to start from scratch, and let's start by adding our vector. I'm going to paste this in. This is how we create a what we call a container, and quickly this is what you're looking for right here, vector. The scope is this right here, and typically with any STL containers in a standard template library, you're going to have to do this junk in front of it, part of its namespace. I'll get to that later in other videos, but for now it's just a simple matter of you type standard, and then if I wanted vector, there it is right there. The way this notation works, if you're not familiar, is these left and right arrows. You would put in the type that will be held in a container. It can be anything. It can be an integer, it can be a char, but in this case, we're putting this class in here of automobile, and we're stuffing it into here, and we're going to say, hey, we're going to have a container filled with automobiles, and then we're going to call it cars. The next step is, this is empty. We need to put data into it, and very easy to do. We have, there are many methods in the vector class, and we're going to do it this way. The pushback function to what they call to the back of the queue, and then as you take off the front, that's the oldest, and the back would be the newest. So pushback is your friend. Since we are initialized, we can initialize and stuff into the vector. This is a quick way of doing it. So what we want to do is we want to add to this container dynamically, and you can simply instantiate objects of the type automobile. Let's say for this example, we call it car, and then we can initialize that struct right in here, then add it right to car, where the initializer is done for you inside the constructor. Now, if you're happy with breaking it down and filling in all the properties, and that's fine. I'm just showing you different ways of doing things, and then I'm going to show you a quick and easy way, which is what you would typically see, is something like this. That's if you know the data ahead of time. Now we can test our code, see if it works properly, and let's run it. And we are stopped right at the beginning of main. We hit run, and there we go. We see our container is now filled with the appropriate values. So I will be right back. On the next step, I will show you how we can dynamically add additional to this container and even remove. Okay, we're back. So what I did is I added an additional vehicle. I added a Chevy Malibu on this line, on line 37. We can pretend that in between we were doing other work. We ran off, we did some other process, and now we come back, oh, we'd like to add another vehicle. Well, if you're in C, unless you pre-allocated that slot, you're fine. But what if you didn't? You have to use malloc or some other trick, like I had said in the earlier example. But with the vector, it's quite easy. You can just do another pushback. And when I run this, you'll see what I mean. We have the original 3, and now we have the Chevy Malibu at the end. So now we have 4 vehicles. And likewise, I can continue to add more vehicles as we want. And I will demonstrate next how we can actually remove from this container and not have to worry about reclaiming memory. It's all done automatically for you under the hood. So finally, one of the final things I want to show you is we can remove from the container. Now, right now, the container has a size of 4. Finally, I want to show you how to do a erase. Currently, we have 4 vehicles in the cars container. Let's say I want to remove the Ford Mustang. Well, that would be index number 2. Remember, everything in the container, just like in arrays, index start at 0. So 0, 1, 2, I want to eliminate the Ford Mustang. One of the methods in the vector class is called erase. And you start with, you pick the location by what's called an iterator. I will get to that in other videos, but it's simply +2 from the beginning. And when we run the code, and of course I forgot to put the print statements there. Run. We are now back down to 3, and the Mustang is no longer in there. If you notice, Chevy, which was index 3 at one time, or car number 4, is now car number 3. So the internal structure of this vector container has changed. You have to keep this in mind, and I will get to this in later videos, that when you're using iterators, an iterator is really a kind of a smart pointer that the container uses that you can navigate through it. Once you delete an object, those iterators, the iterators become invalid. So what you thought was index 3 at one time is now going to become index 2. So you have to keep that in mind when you're dealing with these. If you create one of these containers and you never change it, it's not the end of the world, as long as you know where everything is. But once you remove something from the center, that memory is going to move memory around dynamically, and the container is going to shrink by 1. So any indexes that you had previously become invalid. Something to keep in mind. Doing this in C would have been very complicated. In the previous examples, I didn't even go over doing an erase. I only did a malloc. And malloc here is easy. Every pushback, you're allocating new memory under the hood. So it's pretty straightforward. And then when you're done, you access this cars vector just like you would an array. You can use index notation, the square brackets, just like you would with a C-style array. The advantage is now when I access cars, I can get its size. I can get properties inside, such as the make and the year. But you have a lot of other things that are available to you that are kind of inherited from the vector class. Size is one. There's another one called empty. It returns true or false if the container is empty. And again, this is just an introduction to get you start thinking of how I can really manipulate arrays, but that were once C-style arrays that would have been kind of a pain in the butt to do in the land of C. But in C++, it's actually pretty straightforward. And if you look at this code, the final version, if you remove print statements, which we only had in here for debugging purposes, if I go through and remove those, that's not that much code. If you remember our previous examples in C, it was easily 100 lines of code. Here in this case, I'm adding to the container. I even took away, and I did it in like 7 lines of code. that's one of the advantages of using C++ and using the standard template library. If you want to learn more about vector, one of the places I use quite a lot is cplus.com, and you can search it from Google too, but from here you just type in vector. Right there it is. This is the standard vector class template, and then you can look up all of the operators that we were discussing. For example, there's pushback right here. Then they give you some nice examples. They'll even let you run it in the window here, which is really cool. They talk about the iterator validity, which I had mentioned. The other one we used were size. Returns the number of elements in the container. And you can just go through it and explore all these and see what you can do. Another one we used was erase. And it's overloaded, so you can actually do multiple things. You can call erase in several different ways. So cplus.com I recommend is a good place to go when you need references for the standard template library, and any other place you want. Well, everyone, thank you very much for watching my video and staying all the way to the end. I hope you've learned a lot. This is my first video, and there might be a few mistakes here and there, and hopefully going forward I will perfect all these little minor issues. So if you can, give a like, welcome the subscription, and I will see you on the next one. Take care. That I know is that I'm here, I don't know, except that